Hello friends, welcome to my channel Patra Tutorial. In this video I'll be discussing about the solution to critical section problem using turn variable. Okay, so this is the first approach using software technique. Okay, as I discussed in the previous video, there are three different methods are there. First one is what, using turn variable, second one is using flag variable, and third one is Peterson solution. Okay, actually the first two solutions are wrong solution. Okay, but we have before understanding to understand Peterson solution, we have to understand these two wrong solutions first. Okay, and first we will discuss means we will try to solve for two processes. Okay, so first we'll try for two processes. Okay, and then we'll go for the n processes. Okay, so first we'll see how difficult it is to solve for the two processes. Okay, and then we'll go for the n process. Okay, so the this solution using turn variable is for only two processes. Okay, so in this approach we have only two process. Okay, and two process share one common variable, that is called turn variable. Okay, and this is one integer type, and turn, the value of turn is either 1 or 0. Okay, the value of turn is either 0 or 1. Okay, and the variable turn indicate whose turn it is to enter the critical section. Okay, we are solving for two processes, right? And if the value of turn is 0, then maybe p1 will be entering into the critical section, and if it is 1, then maybe p2 will be entering into the critical section. Okay, so let's discuss in detail this one. Okay, so in this approach, or in this algorithm using turn variable, we will be solving for only two processes. Okay, so just let me take one process here. So suppose this one is process p1. Okay, and the codes are given here. So this is the lines of codes the p1 is having, and there is another process called p2 here. Okay, and actually these two processes are same processes. Okay, only the difference is that when the value of turn, initially the value of turn equal to 0. Okay, let's say turn equal to 0. You can take 1 also, there is no restriction. Okay, and for the understanding I am taking 0. Okay, so suppose the value of turn is 0. Now just look at this program. Okay, so as I discussed in the previous video, before entering into the critical section, the process must go through the entry section, right? There will be one entry section, and before leaving the critical section, means while leaving, it will go through the exit section. Okay, so what entry section will do? So in this program, this part of the program, see, this one is very important one, right? So this is the, and this part of the program in this process p2, this one. Okay, now see, this one is the entry section, right? Because in this while loop, it is checking whether the value of turn is 0 or 1, right? If it is 0, see, while turn is not equal to 0, that means what, while 0 it will enter to the critical section, but while turn is not equal to 0, it will do nothing. Okay, that means what, it will keep repeating here only, in this loop only. It will check, if it is not 0, then again do nothing, again it will come to while, again check, not 0, then again do nothing, again come back to while. So it will be repeating here only. Okay, same thing in this program also. If the turn is not 1, that means it is, if it is 0, then what it will do, it will do nothing, and it will just keep repeating here only. Okay, so until the value of turn is not 1, it will be repeating here only. Okay, so this is the entry section. That means what, if the value of turn is 0, that means p1 can enter into the critical section. If the value of turn is 1, p2 can enter into the critical section. Okay, and see, now look at the exit. This is the exit section, right? So after completing execution in critical section, the process p1 is giving turn to the process p2. That means what, it is making the variable turn equal to 1. Okay, so previously it was 0, so it is changing the value to 1. Okay, now p2 can enter into the critical section, because it is rotating, means it is in loop only, right? While loop it is executing. So once it becomes 1, then it will not satisfy this condition, then it will go to the critical section. Okay, now see, suppose let me check one by one condition. Okay, so first one is what, mutual exclusion, right? So there are three conditions are there for critical section problem solution. First one is what, mutual exclusion. Okay, now let me say, suppose turn equal to initially 0. Okay, now when turn equal to 0, P2 cannot enter into the critical section, right, until P1 is completed. So what it is happening is, it will come here. Okay, suppose P1 is trying to enter into the critical section. Now it will check here, while turn is not equal to 0, but it is 0, right? So condition is false, means what? It will go to the critical section, it will not execute this part. Okay, now it will execute in the critical section. Then while coming out of the critical section, it will change the value of turn to 1. Now it is 1. Okay, and it will execute the remainder section. In remainder section, the process access the private resources. Okay, so private resources are nothing to do with the other process, so it can continue its execution. Now P2 try to enter into the critical section. Then once the turn variable becomes 1, immediately this condition will not satisfy, right? Because it is saying not equal to, but it is equal to 1, so it will not execute this part, it will directly go to the critical section. Okay, and again while leaving the critical section, it will change the variable turn to 0. That means what? Again it is giving the chance to process P1. Okay, then again it will the process, if process P1 again wants to enter into the critical section, it can enter. Okay, that means what it is happening is, P1 is giving chance to P2 and P2 is giving chance to P1, right? And since the variable of turn cannot be 0 and 1 simultaneously, the value of turn will be either 0 and or 1, right, or 1. So only one process will be there in the critical section, so the mutual exclusion condition is satisfying, right? So P1 enter the critical section only if turn equal to 0, and P2 enter the critical section only if turn equal to 1, right? And turn variable cannot be both 0 and 1 at the same time. Okay, so this condition is satisfying very nicely. Okay, and what was the second condition? Progress, right? What about progress requirement and bounded waiting? Okay, progress means what? If now let me take this example again. Let me start the program again. Okay, suppose turn equal to now 0 again. Let me check whether the progress is there or not. Suppose P2 doesn't want to get into the critical section, so at that time, suppose P1 wants to again enter into the critical section, whether it can be done or not. Okay, so initially turn equal to 0, and now P1 is trying to enter into the critical section, P1. Okay, so P1 will be checking this one, while loop, while turn is not equal to 0, but it is 0, so condition is not satisfying, it will not execute this part, it will go to the critical section. Fine. Okay, so then P1 will execute in the critical section, then it will come out of the critical section, right? So what it will do, while coming out of the critical section, it will change the value of turn to 1, right? So now let's change it to 1. Okay, now the value of turn is 1 and it completed. Okay, suppose P1 completed. Now P1 completed its execution. Okay, now suppose P2 doesn't want to get into the critical section now, and P1 again trying to enter into the critical section. Okay, so that is what progress, right? If only those process who are trying to enter into the critical section will be competing for the critical section, right? Now P2 doesn't want to get into the critical section. Now P1, this is P1. Okay, now P2 doesn't want to go to the critical section, and P1 again trying to get into the critical section. Okay, so now see, now the value of turn is what? 1. Okay, now P1 will start here. Okay, and it will check while turn is not equal to 0. Yes, because turn is 1 right now. Okay, so this condition is satisfying, so it will execute this part, do nothing. Again it will come, again it will check while turn is not equal to 0. Yes, again it will do nothing and come here. And since the value of turn is right now 1, and that will only be updated by P2, and P2 does not want to go to the critical section, so it will not execute this part, and P1 will also be in waiting state only, means in this loop only. It cannot, it never get into the critical section. Okay, until and unless P2 is not executing the critical section and updating the value of turn to 0. Okay, so that is the problem, that is not progress, right? See, there is no one in the critical section. Okay, but P1 is not able to enter into the critical section. Okay, so that is the problem. Okay, so even if there is no one executing in the critical section and P2 is not interested in critical section, still P1 is not able to get into the critical section. That is not progress. Okay, so progress is not satisfying this solution. Okay, so in this solution we are not getting the progress. So this is the wrong solution. I will discuss in the next video what is how turn variable is used for the solution. Okay, so for this video just you understand what is turn variable and how it is useful for critical section. Then I will discuss in the next video. Thanks for watching and see you in the next video.